Learning goals for this section are: I can use Pythagorean theorem to find an unknown length and can determine when it is appropriate method to use. I can use the distance formula to find an unknown length. So Pythagorean theorem, if a triangle is a right triangle, so that is key. We have to have right triangles. Then the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So our hypotenuse is always across from our right angle. So that's one way to remember the hypotenuse. It's always across from the right angle. And then our other two sides of our triangle are called the legs. Okay, and then here's our formula. It's c squared equals a squared plus b squared. So c squared is your hypotenuse. And again, your hypotenuse is across from your right angle. When using Pythagorean theorem, remember the triangle has to be a right triangle, so I said that. And then your hypotenuse, the longest side, has to be by itself. So in our first picture, we're going to find the unknown side length and then round to the nearest tenth. First picture, across from our right angle, that is our c. So c squared equals 3 squared plus 4 squared. C squared equals 9 plus 16. C squared equals 25. Now to undo a squared, we use the square root. Square root of 25 is just 5. So we don't have to round with this one. It gives us a nice even number. So this side length of AB is 5. Okay, our next picture. Finding our unknown side length. Well, across from our right angle, this is our C, which means this is our A and our B in no particular order. So we know that 10 squared is equal to A squared plus 6 squared. Remember, our C has to be by itself on one side of the equal sign. So 10 squared is 100. A squared plus 36 minus 36 from both sides. So 64 is equal to a squared. Take the square root on both sides to undo that squared. So we know that a is equal to 8. Again, this gives us a nice whole number. Now we need to round yet. So that means that this side over here is 8. Okay, our next picture, we're trying to find PQ. So across from our right angle is our C. So C squared equals 2 squared plus 5 squared. C squared equals 4 plus 25. C squared equals 29. To undo our squared, we're going to do a square root. So square root of both sides, we get C is equal to 5.385. But we need to round. So round. So our final answer for PQ is 5.4. Okay, so just remember our rounding rule. If it is 0 through 4, you round down. 5 through 9, you round up. Okay, our next picture. Across from our right angle is our C. So that means that this is our A and B. So 9 squared equals A squared plus 6 squared. 9 squared is 81. A squared stays the same, plus 36, which is 6 squared, minus 36 on both sides. A squared is equal to 45. Take the square root on both sides to get rid of that squared. So we get A is equal to 6.708. But remember, we need to round. So our answer is 6.7. Remember that 0 tells us to round down, so 6.7. Okay, applications of Pythagorean theorem. We always need to be drawing a diagram. So Sam drove about 150 kilometers east and then another 75 kilometers north. What is the approximate air distance from her starting location to ending location? So remember our directions. So they drove, so here's your start, drove east, then drove north, and that's the finish. And then the air distance is what we're looking for. That would be our x. So we went 150 and then 75. And because we went east and north, that means we have a right angle in our picture. Our x, our unknown, is across from that right angle, so that's kind of like our c. So we know that x squared is equal to 150 squared plus 75 squared. I'm going to put that in my calculator. So this goes in my calculator. We get x squared is equal to 28,125. Take the square root on both sides. We get x is equal to 167.7 kilometers. Perry wants to replace the net on his basketball hoop. The hoop is 10 feet high. Perry angles his 12-foot ladder out from the base of the basketball pole. So let's draw our picture. So here is my basketball hoop with my little net. And then here's the ground. And then I have my little ladder. Okay, there's my picture. So the hoop and the ground make a 90-degree angle, so right angle. Our hoop is 10 feet high. The ladder is 12 feet long. And then we want to know how far is the ladder from the base of the pole. So here's our x. Across from our right angle is our c. So that means that x is like our a. So we have 12 squared equals x squared plus 10 squared. So 144 equals x squared plus 100 minus 100. So we get 44 equals x squared. Take the square root of both sides. X is equal to 6.6 feet. The stairway has 20 steps. Each step has a length of 22 centimeters and a height of 15 centimeters. Find the height, calculate the length of the handrail. So instead of drawing 20 steps or whatever, I'm just going to do, here's our big stairway. So 22 times 20 is 440. So that means the length is 440. Our height would be 15 times 20, so that's 300. So this would be 300. The handrail, remember, is going to go this distance. That's going to be an x. So x squared is equal to 300 squared plus 440 squared. X squared is equal to, okay, I'm going to put this in my calculator. So all of this in my calculator, we get 283,600. Okay, take the square root of both sides. So we get x equal to 532.5 centimeters. Okay, flip the page. Finding length on a coordinate plane. Well, we want to find AB. So we have a couple different ways of finding AB. So what we're going to do is, first I'm going to draw a triangle. So here's my triangle. So we have 1, 2, 3, 4, 5 this way, and then we have a right angle, and then we also have 4 distance this way. That means AB is our C because that's across from our right angle. So option 1 is we're going to use Pythagorean Theorem. So we have C squared is equal to 5 squared plus 4 squared. C squared is equal to 25. 4 squared is equal to 16. Add them together. We get 41. Take the square root of both sides. So we get C is equal to 6.4. So that's this length right here, 6.4. Option number 2 is, so this option number 1 we use Pythagorean Theorem. Option number 2 would be using the distance formula. So distance formula is we're actually going to use our coordinates. So A is at coordinate -1, 1. B is at coordinate 4, 5. So here is the distance formula. It's finding the distance between 2 points and then plugging them into our formula. So what we do is we take our points. So here's our big square root. Make sure everything's under our square root symbol. And we have our x1, y1, x2, y2. So x2 is 4 minus -1 squared. That's just following this formula right here. And then we have 5 minus 1 squared. So 2 negatives make a positive. So we actually have 5 squared plus 4 squared. 5 squared is 25. 4 squared is 16. Add them together. We get square root of 41, which we know from the last problem is 6.4. So what do you kind of notice the similarities here? So we have some similarities. We have 5 squared, 5 squared, 4 squared, 4 squared, and at the end we have everything being square root. So distance formula actually comes from using the Pythagorean Theorem. So now let's just practice our distance formula again with 2 more problems, and then we're done with our section. So first thing we're going to do is we're going to label our points. So I like to label them x1, y1, x2, y2. So our distance is equal to the square root. So make sure your square root's long enough because everything has to be underneath our symbol. So we have -5 minus 6 squared plus 3 minus -2 squared. -5 minus 6 is -11 squared, plus 2 negatives are positive, so plus 5 squared. It is important to keep the parentheses. -11 squared is actually -121, but in parentheses, -11 squared is positive 121. So we have positive 121 plus positive 25. 121 plus 25 is 146. So the distance is 12.1. Remember, that's rounding to the nearest tenth. Okay, next problem. Again, first thing I want you guys to do, label x1, y1, x2, y2. It is important to keep the 1's together and the 2's together. Doesn't matter the order. I honestly could flip them around if I wanted to, but all that matters is that the 1's are together and the 2's are together. So the distance is equal to, so it's x2 minus x1 squared plus y2 minus y1 squared. Be careful with your negatives. So we have negative 5 squared plus 14 squared. Because the negative 5 is in parentheses, this turns into a positive 25 and a positive 196. Add those together, we get 221. Take the square root, so our distance is 14.9. Okay, so look back over your learning goals. What did you notice? What do you feel you know at this point in your learning? What are you unsure of? Do you have any questions about the formulas, how you get numbers, where numbers come from? So go ahead and fill this all out.